use of a calculator or the use of a unit circle, which is why you probably haven't even noticed, but we covered up all the unit circles. We turned all the unit circles around all the way around the room and all that fun stuff. Okay? So, without the use of a unit circle or a calculator, we want to evaluate these four things. Okay? So, cosine of inverse sine of negative root 3 over 2. So if this were me, what I would be doing is I would be saying to myself, where is sine equal to negative square root 3 over 2 on the right half of the unit circle? Because this right here is saying that right half of the unit circle. So where is sine equal to negative square root 3 over 2 right half? What do you got?
Well, 60 degrees is square root 3 over 2, so negative would be the other.
What do you got?
I think it's negative pi over 3.
I like negative pi over 3. Yeah. Okay. Oops. My bad. So this is the cosine of negative pi over 3. Right? So what is the cosine value then at negative pi over 3? Positive or negative?
Positive.
Man, it didn't change.
Positive half.
Positive half?
Yeah, I think so.
Okay. Do we agree then that this answer here would be 1/2? Yeah, I'd agree with that also. Yep. Why these aren't highlighted, I don't know. Again, first time for everything. Okay? Inverse sine of the sine of 5 pi over 3. Okay? So, first question you got to ask is, what is the sine of 5 pi over 3? Just color coding the last one. What is the sine at 5 pi over 3? Negative root 2 over 2? Do we agree with negative root 2 over 2? I don't agree with that at all. Negative square root 3 over 2? Do we agree with negative square root 3 over 2?
Yes.
Okay, because 5 pi over 3 is 3 pi over 3, 4 pi over 3, 5 pi over 3 is down here, right? Okay, so that's negative, so that's at the point 1/2, comma, negative square root 3 over 2. Right? So this is going to then become the inverse sine of negative square root 3 over 2. Which is what? negative pi over 3.
Sine is restricted to.
The right half, yep. Normally, the inverse sine and the sine would cancel each other out. But because we've restricted the sine's inverse's range, then we have to change it to negative pi over 3. Okay? Tangent of arc cosine of negative 8 over 17. This one is not on the unit circle. Which quadrant am I dealing with? I'm in quadrant number 2 because cosine is restricted to the top half of the circle. So I'm dealing with that. This would be my theta prime. This would be my theta. Okay. So arc cosine is what? Ka, so adjacent over hypotenuse. So this is going to be negative 8 in there and 17 in there. Missing side, 15. Pythagorean triple, 8, 15, 17. Side note, Friday's quiz is a non-calculator quiz, so you should know your Pythagorean triples. 3, 4, 5, 6, 8, 10. 8, 15, 17, 12, what? What? 12, 13, and 5. No. Or any multiples of those, you know what I mean?
Yes.
So 3, 4, 5 is 6, 8, 10. Is 9, 12, 15. Okay? You know what I mean? Okay? So the tangent, so the arc cosine of that, don't even need to worry about that because I'm dealing with, we'll call this my theta, because this is a theta finder, right? Okay? So I'm really looking here for the tangent of that angle theta. So tangent is what? Opposite over adjacent, right? Okay. So the opposite side is, so the opposite side is 15, the adjacent side is negative 8, so we would write this as negative 15 over 8. That's the why it's circled, yes. Have picked up on that yet? I do that little, I've been doing that all year. Arc cosine of 2x, and then we want to take the secant of that. So secant of arc cosine of 2x. Which quadrant am I in? First quadrant, yep. In the first quadrant, my angle is my reference angle, so that's my theta there. Cosine is what again? Adjacent over hypotenuse. So that would tell me that the adjacent side is 2x and my hypotenuse is 1. On this particular one, we need to do a little Pythagorean type theorem. So we're going to square my 2x, and we're going to square 1. So that would give me 4x squared plus y squared equals 1. Y squared is going to be 1 minus 4x squared. So y, my opposite side, is going to be the square root of 1 minus 4x squared. Truly, it should be plus or minus, correct? But because I'm in quadrant number 1, it has to be positive. Okay? So this then becomes the square root of 1 minus 4x squared. Okay? So I need the secant of my theta secant is 1 over cosine, right? So that's 1 over x, right? So what do we get? 1 over 2x? Right? Okay. So another way of thinking of it is, so secant of theta is 1 over the cosine of theta, right? The reciprocals. Okay. Cosine of theta was 2x over 1, right? Okay. So this is 1 over 2x over 1. Flip and multiply. 1 times 1 over 2x gets me 1 over 2x.
So we didn't even find the other.
In this particular case, we didn't, but if it would have been cosecant, yes, or cotangent, or sine, or tangent, or, yeah. We like words being short. But, yeah, but like, so because in this one, because secant and the cosine are, you know, in your brain by now, you should be able to pick out that secant and cosine are going to cancel each other out. Okay? Good? Okay. Love it. So, today, that's the notes that I had for today. So what I would like to do now is we have a formative that we would like to be taking. So we're going to take that now. When you're done with the formative, I have a review packet for Friday's test that you can be working on. And then tomorrow we'll be doing the reviewing part, and then Friday we will be doing the quizzing part.